Now I'll discuss the last topic from this chapter, which is transformer. So what is transformer? What is its basic principle? Explain its construction and working. Every locality, the electricity board, they placed a transformer. The main duty of transformer is to increase or decrease the voltage. So while voltage increase or decrease, the current decrease or increase. That means with the increase in voltage, current decreases, so that the power remains the same. Power means voltage into current. So to power remain the same, if voltage increase, current must decrease. That's why what is transformer? A transformer is a device which can increase or decrease the voltage of AC supply with the corresponding decrease or increase. That means when voltage increase, current decrease, and when voltage decrease, current increase. So a transformer is a device which can increase or decrease the voltage of AC supply with the corresponding decrease or increase, not increase or decrease. There is decrease or increase in current. And a transformer based on the principle of mutual induction, which we have already discussed. That means it is based on the principle of mutual induction. That is, when current through a coil changes, and EMF induced in the neighboring coil. So what are the basic components of this transformer? So now we'll discuss about the construction of a transformer. A transformer consists of two windings. That means two coil. Windings mean coil. Two coil. The one coil is called primary coil and another coil is secondary coil S. Primary P and secondary coil S. The windings connected to AC source is called primary windings, mean the coil which is connected to the source of AC voltage is called the primary coil, and the coil which is connected to the load, mean output, is called the secondary winding. The AC power is transformed from primary to the secondary through the load resistance RL. So this is the diagram for transformer. So a transformer has two winding. One is winding, this is the one winding, one coil which is connected to the AC source, and this coil is known as primary coil, and another coil is connected to the load through which we get output power here. Here we get output power, here we get input, where here we apply input power. And these are iron plate, soft iron plate core. So this is the basic parts of a transformer. So now how does it work? Well, so first we consider VP, applied voltage to the primary coil, and VS, output voltage across the secondary coil, NP, number of turns in the primary coil, NS, number of turns in the secondary coil, EP is the EMF induced in primary coil, ES, EMF induced in the secondary coil. And from Faraday's law of electromagnetic induction, we know that E is equal to minus N d phi B by dt. So therefore EP equal to minus NP d phi B by dt. ES equal to minus NS d phi by d phi B by dt. If you take the ratio of ES by EP, so ES by EP equal to minus NS d phi B by dt minus NP d phi B by dt. If we cancel d phi B by dt, d phi B by dt, and minus minus cancel, then we'll get ES by EP equal to NS by NP. But for an ideal transformer, EP equal to VP and ES equal to VS. Therefore, ES by EP equal to NS by NP equal to VS by BP. And for an ideal transformer, I have already told you, output power equal to input power. Power means voltage into current. Output is Vs Is, because output is secondary coil. For secondary, voltage is Vs, current is Is, and input is in the primary. Primary means voltage applied in primary is Vp, current through primary is Ip. So therefore Vs by Vp, if Vp bring to the left side, Vs by Vp, then Is will come to the right. So Ip by Is. Therefore we can write Es by Ep equal to Ns by Np. But Es equal to Vs. So Es by Ep equal to Vs by Vp equal to Ns by Np equal to Ip by Is. Not Is by Ip. Ip by Is. And the term Ns by Np, this is known as transformation ratio, denoted by small k. If the value of k is greater than 1, the transformer is called step-up transformer. And if the value of k is less than 1, then the transformer is called step-down transformer. That means there are two types of transformer. One is called step-up, another is step-down. Step-up means, that means which convert low voltage into high voltage. And step down means high voltage to which convert high voltage to low voltage. So what is the effect of voltage and current in transformer? So we know that Vs by Vp equal to Ns by Np equal to Ip by Is. So if Ns by Np is greater than 1, then that is Ns greater than Np, then if Ns greater, Vs greater than Vp, and Ip is greater than Is. I see Ns greater than Np and Vs greater than Vp, but Ip less than Is, means Is greater than Ip. That means for step-up transformer, output voltage, this Vs means output voltage increases but output current decreases. That means when voltage increase, current decrease. That means step-up transformer is a transformer which convert low voltage to high voltage, means low voltage at high current changes to high voltage to low current. So if Ns by Np less than 1 for step-down transformer, so Ns less than Np, Vs less than Vp, but Is greater than Ip. Thus for step-down transformer, output voltage decreases but output current increases. Now we'll discuss another very important topic, which is different types of energy losses in transformer. So the first energy loss in transformer is flux leak. Flux leakage. Flux means number of magnetic field line passing through the coil normally. So there are two coils, one is primary coil, another secondary coil. And since it is based on the principle of mutual induction, that means flux is transferred from primary to secondary. But while flux transfer from primary coil to secondary coil, some of the fluxes they loss into air, and this is known as flux leakage. The magnetic flux produced by the primary coil may not fully pass through the secondary coil. Some of the flux may leak into air, and this leakage of flux can be minimized if the primary and secondary coil they overlap each other. You see, it can be minimized by winding the primary and secondary coil over one another. The second loss, energy loss in transformer is resistance of the winding, which is known as copper loss. That means for primary and secondary winding we use copper wire, and when current pass through the copper wire, they offer resistance. As a result, heat produced in the wire, and this is known as resistance of winding. So resistance of winding, the wire used for winding has some resistance, so energy is lost due to heat produced in the wire. And if we use thicker wire, and we know that thicker wire has less resistance than thinner wire. We have already learned in class 10. That means instead of using thin copper wire, if you use thicker copper wire, the loss of energy decreases. That means resistance of the wire decreases. As a result, heat produced in the wire will also be decreases. That means there will be less loss of energy. So, and the last loss of energy in transformer is eddy currents. We have already learned when magnetic field line passing through a metal block changes, eddy current develop. Here the core of the transformer is made of iron. So when magnetic flux passing through the iron core changes, eddy current produced, and due to eddy current, heat produced on it and energy lost. So, and this loss can be reduced by using, instead of block, if we use laminated iron plate. So eddy currents, that changing magnetic flux induces eddy current in the iron core, which leads to loss of energy in the form of heat, and this loss can be reduced by using laminated core. Instead of using block of iron, if we use the laminated plate of iron, the loss of energy due to eddy current can be reduced. Now we'll discuss some numerical problems related to transformer. So a transformer has 100 turn in primary, that means NP equal to 100, and 200 turn in secondary, NS equal to 200. If the voltage and current in the primary, that means VP 220, IP 10 ampere, what will be the corresponding voltage and current in the secondary coil? So we know that Vs by Vp equal to Ns by Np equal to Ip by Is. So Vs we don't know, Vp 220, Ns is 200, Np 100, Ip is 10, Is we don't know. Vs by 220, but 200 by 100 equal to 2, 10 by Is. Therefore, Vs by 200 equal to 2 and 10 by Is equal to 2. So therefore we can write Vs equal to 440 volt and Is equal to 10 by 2 ampere, which is equal to 5 ampere. Now we'll discuss another numerical problem. This is also related to transformer. A power transmission line fetches input power. Input power means Vp into Ip. So input power is input power at 2300. That means this is the input voltage. This is 2300 volt. Fetch input power at 200 or 2300 volt. That means Vp equal to 2300 volt to a step down transformer with its primary windings. Primary means Np equal to 4000 turn. What should be the number of turn in the secondary in order to get output power at, that means output voltage Vs equal to 230 volt. So Vp 2300 volt, Np 4000, Vs 230 and Ns. So this is the formula we have. Vs by Vp equal to Ns by Np. So Vs is 230 divided by 2300, Ns by Np is 4000. So if we cancel, it will get 1 by 10, Ns by 4000. If you cross, Ns equal to 400. That means number of turn in the secondary coil is 400. And that's the end of chapter 7.